Deep in the rugged Himalayas, where temperatures swing from scorching heat to freezing cold, lies one of the most daunting construction challenges ever faced. Imagine building a giant steel bridge across a canyon where winds roar at speeds higher than most hurricanes, and earthquakes are a constant threat. This is not just any bridge. It connects isolated regions separated by hostile mountains, making travel nearly impossible for decades. After more than 20 years of hardships, including treacherous terrain, political tension, and sheer logistical nightmares, India has finally completed a structure that many believed could never be built. The Unseen Challenge. The Chenab Bridge is not just remarkable for its record-breaking height, but for the brutal environment in which it was built. Located deep in the foothills of the Himalayas, the site is a place where temperatures swing drastically, from blistering 50 degrees Celsius in summer to bitter freezing winters. The landscape itself is unforgiving, shaped by jagged cliffs and deep canyons carved by the fast-flowing Chenab River. Just reaching the location was an ordeal, involving treks on narrow, dusty trails or risky boat journeys along turbulent waters. In a setting like this, the idea of hauling tens of thousands of tons of steel seems almost impossible. Adding to these physical hurdles was the fact that no conventional infrastructure existed nearby. No motorways, no flat areas to stage materials, and no factories to prefabricate heavy components. Every piece of steel had to be transported carefully through treacherous mountain roads, often built specifically for the project. The working conditions pushed construction crews to their limits, not only battling the twin extremes of heat and cold, but also contending with violent winds that can gust up to 165 miles per hour. Conventional construction methods were simply inadequate here, demanding innovative approaches and extraordinary determination. Yet, as daunting as temperature and terrain were, they were only part of the puzzle. The teams had to prepare for relentless windstorms that could easily endanger workers high above the canyon floor. On top of that, the area is seismically active, raising the stakes even higher. Any one of these challenges alone might have halted the project, but combined, they created an environment where building a bridge felt borderline impossible. What it took to overcome these obstacles will become clear as we explore the purpose and strategies behind this incredible feat. The tough environment and physical barriers shaped not only how the bridge was built, but why it had to be built in the first place. Strategic location and purpose. The Chenab Bridge is a vital piece of a much larger puzzle, connecting the northern region of Jammu with the Kashmir Valley, two areas separated by harsh mountainous terrain. For decades, the main route between them, National Highway 44, was frequently blocked by snow, isolating communities for months at a time. This bridge forms part of India's new 169-mile all-weather railway line, designed to cut straight through the mountains and maintain reliable year-round access. The goal is not just improving travel, but ensuring economic growth and stronger ties for a region often marked by instability. The area of Kashmir exists as one of the world's most heavily armed and politically volatile regions, which India and Pakistan jointly control. The existing tensions in this area create difficulties for construction projects. Critics argue that such developments extend political control over the region, while supporters believe that improved transportation links will lead to peace and economic development. The construction work continued despite the existing disputes because it linked together various construction points which included bridges and tunnels that served as unique engineering achievements. The entire rail line system includes 900 bridges together with 36 tunnels, which contain one tunnel that extends to almost 7 miles of length. This railway system provides more than just mountain crossings because it demonstrates dedication to building both regional unity and the capacity to withstand challenges. The Chenab Bridge itself stands as the main part of the project, which demonstrates how one bridge can hold great military importance. The team needed to face natural obstacles because they had to build every meter of track together with every steel truss which formed the structure of their project. With purpose firmly established, the next step was to tackle the natural forces that threatened to undo the project entirely. Engineering against nature. Nature here is anything but forgiving, and the engineering needed to meet those conditions was unlike any other bridge project. The massive swings in temperature mean the steel must expand and contract daily, sometimes unevenly, creating stresses that require special design solutions. Even more intimidating is the wind, intensified by the canyon's shape. Known as the Venturi effect, it turns the narrow gorge into a funnel where wind speeds accelerate dramatically, whipping up chaotic and powerful gusts that can push against the bridge with tremendous force. This meant engineers had to precisely model wind patterns using physical and computational tests to ensure the structure could withstand gusts far beyond average speeds. The geological context compounds these challenges. The Himalayas are young mountains, still being pushed upward by the collision of the Indian and Eurasian tectonic plates. This constant movement makes the rock formations fractured and unstable. Building a tall, heavy bridge tower on such shifting, fragile ground risked sliding or collapse. To solve this, the Chenab Bridge employs an elegant arch design where the two halves meet in the center and push against each other. This load-sharing system directs the forces into the stable mountainsides instead of relying on any single precarious footing. On top of seismic concerns, sunshine also played a subtle but significant role. The canyon walls block sunlight unevenly, meaning sections of the bridge heat and cool at different rates, causing bending and flexing in the steel. To keep trains safe over this constantly moving structure, the rails were pre-stressed and designed to slide freely within their mounts, absorbing the bridge's natural shifts. Every element had to be meticulously engineered to turn a hostile environment into a stable, lasting connection. This delicate balance between art and science ultimately formed the backbone of India's impossible bridge. The breakthrough designs and natural forces at play set the stage for innovative construction methods that made building in such extreme isolation possible. Before we dive into the clever design that made this bridge possible, take a moment to hit that like button and subscribe. The ingenious arch design. To span the daunting canyon and unstable ground, engineers chose an arch design that works with nature rather than against it. Instead of anchoring towers on fragile rock, the Chenab Bridge rises from opposite cliffs and meets in the middle, locking together like a giant clasp. This distributes the weight outward into the mountains, creating a stable, self-supporting structure that is both elegant and resilient against extreme conditions. The team needed to develop inventive solutions to construct the arch structure. The construction crews began their work by building towers at both ends, which they used to install a cable crane across the distance between the two towers. Engineers constructed the arch structure through a process which began with building its bottom section and used cables to sustain the structure until arch construction reached its highest point. The arch structure functioned as a bridge support when its two sections connected at the midpoint of the structure. The construction team used launching to create the top deck, which extended from both ends of the bridge to form a complete existing bridge structure. The deck functions as a seismic shock absorber, which enables the structure to transform a dangerous canyon area into a safe railway crossing point. The remarkable arch design solved one set of problems, but getting the massive materials to such a remote site introduced another layer of complexity. Overcoming logistical nightmares. Transporting 30,000 tons of steel hundreds of meters above a turbulent river, without highways or factories nearby, demanded extraordinary solutions. To reach the site, the team built over 11 miles of cliffside mountain roads, engineering feats where one mistake could be fatal. Key components arrived flat-packed, like complex furniture, and on-site workshops handled precise cutting and assembly. Working above the ravine brought extreme hazards. Wind, massive loads, and sheer drops required constant skill and coordination. Overcoming these challenges turned an impossible task into a groundbreaking engineering achievement. With materials delivered and the arch established, the final stage brought the project toward completion and long-term impact. The bridge's legacy. Inaugurated in June 2024, the Chenab Bridge is more than an engineering marvel. It transforms connectivity in one of India's most remote regions. Providing a reliable all-weather rail link between Jammu and the Kashmir Valley, it boosts economic development, travel safety, and cultural exchange. Overcoming extreme natural challenges through innovative design, advanced techniques, and decades of perseverance, the bridge is proof of human creativity and determination. After more than 20 years of planning and construction, it stands as a beacon of hope for future projects. Passengers crossing it enjoy breathtaking views while witnessing the result of years of dedication, skill, and relentless effort. The Chenab Bridge reminds us that with determination and innovation, even the most impossible challenges can be overcome. It's a story of engineering triumph carved into some of the harshest mountains on Earth. If you found this remarkable project as inspiring as we do, please like this video and subscribe for more stories that showcase the power of human creativity and resilience.